Assalamu alaikum. My name is Shehroz Khalid with my group members Hussnain Jalil and Ahtisham Ali. Today our topic is GPU, CPU, TPU and VPU. They are the components of computer architectures. Now we discussed on GPU. GPU is a graphic processing unit. In this presentation we see the content like introduction, definition, components of GPU, comparison with CPU, architecture, and conclusion. Now first we see the introduction. Introduction of GPU. A graphic processing unit GPU is a microprocessor that has been designed specifically for the processing of 3D graphics. The processor is built with integrated transform, lighting, triangle setup, clipping, and rendering engines capable of handling millions of math-intensive processes per second. GPUs from the heart of modern graphic cards relieves the CPU central processing unit of much of the graphics processing load. Now we discussed why we use GPU. To provide a separate dedicated graphics resources includes a graphics processor and memory. To relieve some of the burden of the main system resources, namely the central processing unit, main memory and the system bus, which would otherwise get saturated with graphical, operational and IO requests. Now we see what is GPU. A graphic processing unit or GPU also is a dedicated processor efficient at manipulating and displaying computer graphics. Like the CPU, it is a single chip processor. Now we see the difference between GPU and CPU. A GPU is tailored for highly parallel option with the CPU executes program serially. For this reason, GPU have many parallel execution units while CPU has two execution units. GPU has significantly faster and more advanced memory interference as the need to shift around a lot more data and CPUs. GPUs has much deeper pipelines. Now we see the component of GPUs. Graphic processor, graphic coprocessor, graphic accelerator, ARM buffer, memory, graphic BIOS, digital to analog converter, display converter, component bus connector. They are the components of GPU. The GPU pipeline. The GPU receives geometry information from the CPU as an input and provides a picture as the output. Let's see how that happens. First host interference, then vertex processing, and then triangle setup, pixel processing, and the last one is memory interference. Host interference. The host interference is the communication bridge between the CPU and the GPU. It receives commands from the CPU and also pulls geometry information from system memory. It outputs a stream of vertices in object space with all their associated information. Now we see vertex processing. The vertex processing stage receives vertices from the host interference in object space and output then in screen space. This may be simple linear transform or the complex operation involving morphing effects. No, no new vertices are created in this stage and no vertices are discarded. The third one is triangle setup. In this stage, geometry information become raster information. Screen space geometry is the input, pixels are the output. Period of rasterization: triangles that are back-facing or the located outside the viewing functions and rejected. Now the fourth one is pixel processing. Each pixel provided by triangle setup is fed into pixel processing as a set of attributes which are used to compute the final color for this pixel. The computation taking place are including texture, mapping, and math operations. And the last one is memory interference. Pixel color provides by the previous stage are returned to the form buffers, used to be the biggest bottleneck before pixel processing took over. Before the final write occurs, some pixels are rejected by the buffer. On modern GPUs, Z is compressed to reduce frame buffer bandwidth but not size. Now the next topic is CPU, and now I invite Hussnain Jalil to take it.
Assalamu alaikum. My name is Hussnain Jalil as my group member explains about GPU. So I am going to further explain about CPU. CPU, which is also known as Central Processing Unit, its full form is Central Processing Unit. These are the structures of CPU, inside and outside structures of CPU. Introduction. The introduction of CPU. The central processing unit is the portion of a computer system that carries out the instructions of a computer program to perform the basic arithmetical, logical, input and output operations of the system. It acts as the brain of computer. Basically, all the functions are done by the CPU of a computer. Early CPUs were custom designed as a part of a larger, sometimes one-of-a-kind computer. However, this method of designing custom CPUs for a particular application has largely given way to the development of mass-produced processors that are made for this. Standardization began in the era of discrete transistor, mainframes and mini-computers, and has rapidly accelerated with the popularization of the integrated circuits IC. Next, as we can see the block diagram of CPU, how we are giving how we are giving him input and we are gaining the output. Components of CPU. CPU is consist of three components: control unit, arithmetic logic unit, and the registers. Control unit CU, a component which receives the input signal information instruction from the user and converts into control signals for the execution in the CPU. It controls and directs the main memory, arithmetic and logic unit ALU, input and output devices, and also responsible for the instructions that are sent to the CPU of a computer. It fetches the instructions from the main memory of a processor and sent to the processor instruction register, which contains register contents. Next, we can see how instruction register is giving us the input and output, which is we can see as a control bus. Functions of control unit. As we can see, these are following the functions of control unit. First one is it directs the flow of data sequence between the processor and other devices. It can interpret the instructions and control the flow of data in the processor. It generates the sequence of control signals from the received instructions or commands from the instruction register. It has the ability to fetch, decode, handle and execution and store results. It has the responsibility to control the execution units such as ALU, data buffers, and registers in the CPU of a computer. It cannot process and store the data. These were the all functions of a control unit. Next is arithmetic logic unit. What is arithmetic logic unit? An arithmetic logic unit is the part of a central processing that carries out arithmetic and logic operations on the operands in computer instruction words. In some processors, the ALU is divided into two units, an arithmetic unit and a logic unit. Here we can see the ALU of the CPU and how it is related to the CPU. Registers. Registers are a type of computer memory used to quickly accept, store, and transfer data and instructions that are being used immediately by the CPU. The registers used by the CPU are often termed as processor registers. Types of registers. These are following all the types of registers, which are AC accumulator, DR data registers, AR address registers, PC program counter, MDR memory data registers, IR index registers, MBR memory buffer registers. How CPU basically works. The actual mathematical operation for each instruction is performed by a combinational logic circuit within the CPU's processor known as the arithmetic logic unit or ALU. In general, a CPU executes an instruction by fetching it from memory using its ALU to perform an operation and then storing the result to memory. This was all about CPU. Now my group member is further explaining the topic. I will invite Ahtisham Ali for further explanation.
Assalamu alaikum. Myself, Ahtisham Ali. One of my group members, Shehroz Khalid, explained GPU, and the other one, Hussnain Jalil, explained CPU. Now I am here to explain TPU. First of all, what is TPU? TPU stands for Tensor Processing Units. The TPU are Google's custom developed ASICs. ASIC stand for Application Specific Integrated Circuits used to accelerate machine learning workloads. TPUs are designed from the ground up with the benefits of Google's deep experience and leadership in machine learning. Generations of TPU. There are a total of 3 generations of TPU. First generation TPU, second generation TPU, and third generation TPU. First generation TPU and second generation TPU are shown in this slide, and there is the third generation TPU. Now, architecture of TPU. The TPU consists of several key components including the MMU. MMU stands for matrix multiply unit, the systolic array, and the on-chip memory which is used to store intermediate results. Each TPU board is connected to a CPU based host machine to perform operations that cannot be executed on the TPU. The host machines are responsible for loading data from cloud storage, pre-processing data, and sending data to the TPU. Here is a block diagram of architecture of TPU. In this diagram, a third generation TPU is used, which is connected to the host interference, which is further connected to unified buffer, local activation storage, and systolic data setup. Next step is the performance of TPU. TPUs are much faster than CPUs and GPUs. When it comes in training and interference of deep learning models, this speed is achieved by parallelizing operations across multiple chips, which can perform billions of operations per second. TPUs are ideal for deep learning applications that require fast, efficient processing of large-scale datasets and complex neural models. Their combination of speed, scalability, and energy efficiency make them well suited for machine learning and AI applications. Now comes the applications of TPU. TPUs are used in medical. TPUs are being used for medical image analysis and processing, such as magnetic resonance images, MRI, and CT scan images. They can help speed up the process of identifying patterns and abnormalities in medical images, leading to faster and more accurate diagnosis. Second application. The use of TPU in manufacturing can help optimize processes, and reduce manufacturing defects. They can also help identify quality issues in real time and adjust processes accordingly. TPUs are essential for development of autonomous vehicles. They can help us to process complex sensor data in real time, enabling vehicle to make decisions quickly and safely. Future of TPUs. The future of TPU or tensor processing units look very promising as more industries are embracing artificial intelligence and machine learning to gain insights and automate processes. As the demand for more powerful and energy efficient TPUs continues to grow, manufacturers are likely to continue investing in hardware innovations. This may include more advanced chips designs, more efficient power delivery, and new cooling technologies. The future of TPU appears bright as more industries recognize their potential for accelerating AI and machine learning applications. Continued investment in hardware and software optimization as new cases in edge computing and IoT will likely lead to even more advanced and powerful TPUs in coming years. That's from my side. I hope you will understand the TPU and GPU and CPU that is explained by our group. Thank you.